Our next step is to choose the dimension you know the most about and solve for the time the projectile is in the air. So if you look at this, we have three pieces of information for our vertical dimension and only two for our horizontal dimension. So we're going to use this vertical dimension first. And we want to solve for the time because the time that the projectile is in the air is going to be the same for vertical motion as it is for horizontal motion. Now, I need to look at my kinematic equations and find out which one has an initial velocity, a distance, and an acceleration. And so the equation I'm going to use is distance equals initial velocity times time plus 1/2 AT squared. So my initial velocity here, because I'm essentially dropping it, is 0. That leaves me with the distance equals 1/2 AT squared. So I can say 22 meters equals 1/2 9.8 T squared. Well, you might notice that I end up with a negative here and a positive here. Because we're talking about displacement and we're saying that going up would be positive direction, this is actually going to be a negative 22. I'm going to get rid of my little meter mark just to make it a little bit easier to read. So my next step, negative 22 equals, and on my handy dandy calculator, I know that 9.8 divided by 2, or 9.8 times 1/2 is 4.9. And then if I solve for t squared by dividing both sides by 4.9, I get 22 divided by 4.9. That's equal to 4.49. I'm not going to write down all of the numbers here, but I also want to use the number in my calculator, which goes on and on and on, in order to solve for time, because there's no reason to round until the very end. So I'm going to take this 4.4897959 ... and take the square root. And that gives me a time of 2.1 seconds. So the projectile is in motion for 2.1 seconds. Let me just write that a little cleaner. Now we're going to use this 2.1 seconds to look in the horizontal direction.